This is an experiment of showing how sinkholes could form and how it could collapse. The material itself, whether you have clay, you have sand, what kind of sand, what kind of clay, how thick they are, they all play a role. And these things, we measure them as well.
Well, these studies are important because they help us understand the processes that lead to the formation of sinkholes. And from that, we have better predictive tools, perhaps in the future, to figure out where they're most likely to form. The geologists in the room today remarked on how the sediments at shallow depths, how deep they went into the subsurface based on the results of this model.
It was highly interesting for me because I do a lot of the field work associated with the sinkhole vulnerability mapping project that the survey is currently working on. So to be able to see an analog model such as the one behind me is a really great experience for my observations in the field.
This model, as you can see, can be only this big, maybe twice as big at most. The field is much, much bigger. Therefore, you have to do mathematics, build models to help us predict what will happen in the field.
It's really difficult to predict a sinkhole, when and where and how. Yes, this is one way, because we cannot go into the deep aquifer. So this is the only way we can see what happens. And so after this, we're going to have a good understanding. So what's the controlling factor for the sinkhole develops and collapse? And then our goal is to develop some mathematical numerical model, and so we can make a prediction, and then we can have more useful information for the statewide sinkhole protection.